Hello guys, and welcome back to my YouTube channel. Today I'm going to be teaching you all about polynomials and what they really mean. So let's start. Polynomials are, by definition, algebraic expressions that involve only the operations of addition, subtraction, and multiplication of variables. To better understand what a polynomial means, let's look at some examples. Let's go over these examples and see which of these are polynomials. So like I mentioned, polynomials are expressions that only have to do with addition, subtraction, and multiplication of the variables. So the key term there is variables. So everything that's happening when we're looking at whether it's a polynomial or not is that we're looking at the variables, and it can only involve addition, subtraction, and multiplication. So this example, 3x squared plus 5x minus 7. Well, here x is being squared, x is being multiplied, and nothing else is happening to the x's or the variables. So yes, this is a polynomial. Over here, x plus 2. Well, here 2 is being added to the variable. Nothing else is happening. It is, yes, a polynomial. Over here, we have x, y cubed, z. Once again, all the variables are being multiplied together, and this is being cubed, but we know that squaring or cubing anything is just repeated multiplication. So nothing else is happening to the variables. It is a polynomial. Over here we have x minus 5 over 3. So we have the variable 5 being subtracted from the variable, and that result is being divided by 3. Nothing else is happening to the variable. We're not dividing by a variable, we're simply subtracting, and therefore it is a polynomial. There's one example which I want to call to your attention, which is different, which is not a polynomial. If I had x minus 5 over x, this is not a polynomial because now we are dividing by a variable. By definition, polynomials only have adding, subtracting, or multiplying variables. So we cannot be dividing by a variable because it is possible that x could equal 0. And if x equaled 0, whenever we divide something by 0, it turns into undefined. So x cannot be divided by. We can't be dividing by x and still have a polynomial. The next example is the square root of 3 times x. We have x being multiplied by a value, which is the square root of 3, and therefore it is a polynomial because it is only being multiplied and not any other type of function. And over here, our last example is 4. Now it may not look like there's any variables, but indeed we can actually write this 4 as a 4x to the 0, because x to the 0th would just turn into 1. Anything to the 0th power is 1. And 1 times 4 is 4. So the quantity is not changing. We can see that there really is a variable. So here we see the variable is just being multiplied. This is just a constant. And just like our other examples, this is a polynomial. Now we're going to look at some more examples and see whether these are polynomials. So once again, polynomials only involve addition, subtraction, and multiplication of their variables. So in this first example, we have 3 divided by x minus 5. Well, we have here a variable that is being divided by. And like we said before, variables cannot be divided by. So therefore, this is not a polynomial. Over here, we have the square root being taken of x, but polynomials in the definition do not allow the square root to be taken. So therefore, this is not a polynomial. Over here, we have the absolute value being taken of x minus 7. If this was just like this, where it was only x minus 7, then it would be okay because it only involves subtraction of a variable. But now we're also taking the absolute value, and therefore this is not a polynomial because polynomials only can allow addition, subtraction, and multiplication of its variables. We have learned about polynomials. We have to classify them in two ways. Number one, by the number of terms, and number two, by their degree. So first, let's learn about the number of terms. A polynomial that has one term is called a monomial. An example of a monomial would be something like 2x, because it only has one term. If we have two terms in a polynomial, it is a binomial. If we are going to build off this, for example, something like 2x plus 1, you can see it's now made up of two smaller monomials, or two smaller chunks. It's a binomial. Then we have three terms is a trinomial. So an example would be 2x squared plus x plus 1. If we have four or more terms, there's no specific name, and an example will be something like 5x to the fourth plus 2x squared plus x plus 1, because there's 1, 2, 3, four smaller chunks, or four terms. But if we look specifically at a monomial for a second, you can see that each of these with more than one term are still made up of smaller monomials, or smaller chunks. So if we take a monomial for a second, there's another term which we have to know, and that is called factors. And factors are the parts of the monomials. So if I took, for example, 7x squared y, we have to look at all the parts which are being multiplied together. So in this one, we have 7 times x squared, which in other words is x times x, because we're looking at all the smaller pieces which are being multiplied together. So 7 times x times x times y. So these are all the factors in this one monomial. So now that we have learned about how to classify our polynomials based on the number of terms, and we've learned about factors, we're going to now move on to degrees. And degrees are important because we can also classify polynomials based on their degrees. So degrees are basically the maximum number of variables that appear as factors in one term, or one monomial. So in order to understand this, it's best to look at an example. So I have an example here, 3x cubed y squared plus 9x cubed y minus 12x to the fourth y squared. So in order to figure out the degree of this polynomial, we have to look at which monomial, meaning which chunk, which term in this expression has the highest number of variables. So when we add up all the exponents, which term has the highest sum of the exponents? So over here, we have 3 times x times x times x times y, right? because 3x cubed y squared. We can see that there are 5 variables in this monomial. So over here, in this monomial alone, the degree is 5. We can do this simply by adding up the exponents instead of writing it out every time. 3 plus 2 is 5 because we have 5 variables. Over here, we have 3. This y has a power of 1. 3 plus 1 is 4. So over here, we have 4 variables appearing as factors in this one term. 4 plus 2 is 6. Over there, we have 6. So the highest exponent, the monomial with the highest exponent, is the winner. So over here, 6 is the winner because 6 is the largest. So in this monomial, in this polynomial, in this expression, our degree is 6. And one important thing to mention is that if you ever have an expression with something like this, 3 squared x cubed y squared plus 5y to the 5th. And you have to figure out, 5y to the 6th. And you have to figure out what is the degree of this expression. One thing you have to understand is that you can never count the variable or the exponent that comes with the constant. You're only counting the exponents that come with the variable, because this, in essence, is 9, and 9 to the 0th power is 1, so there really is no extra degree in this term. It's just 0. This is just not simplified. So the highest degree here, we're not counting any degrees on constants. So here we have x, so we have 3 plus 2 giving us 5, and over here we have a 6. 6 is the winner because it's the highest. This term has the maximum number of variables, right? It has 6 of these y's. This one only has 3 x's and 2 y's. It only has 5 variables. This one has 6. So this has the maximum number of variables appearing as factors in this term. It has 6. So the winning, the highest, the leading exponents are 6, and that's the answer. It's a degree of 6. So now, based on what we know about figuring out the degrees of an expression, we can classify polynomials by their degree. If we have a degree of 0, as we do in constants, so for example, if I had 12, that's a constant because really it's 12x to the 0. So if I have a degree of 0, it's called a constant, just like 12 is a constant. If I have a degree of 1, it's linear. If I have a degree of 2, it's quadratic. If I have a degree of 3, it's cubic. If I have a degree of 4, it's quartic. If I have a degree of 5, it's quintic. And if I have a degree of 6 or more, there's no specific name. We're going to look at examples. The first type of question that you might encounter knowing this material is when they give you a classification of a polynomial and you have to give an example. So for example, if you have given this quartic monomial, so I have to give an example of a polynomial that is a quartic monomial. Remember, we are classifying polynomials by their degree and by the number of terms. So based on the question that's given, I can tell that the degree of my polynomial is 4 because it's quartic, and that there's only one term because it's a monomial. So an example I would give is 4x to the 4th. I have a degree of 4, and it's only one term. Another example is a quintic binomial. This tells me that we have a degree of 5 and 2 terms. So I can give the example 2x squared y cubed plus 5. Over here, I have our degree of 5 because the highest number of variables in any of the terms in any one of these chunks or monomials, that the maximum number of variables appearing as factors is 5. X times y times y times y. 2 plus 3 gives us 5, giving us our quintic degree. And I have 2 factors. I have 2 terms, rather. 1, 2. So it's making it a binomial. Number 3, a quadratic trinomial. So I need an expression with 3 terms, but the leading degree, meaning the highest degree in any monomial, has to be 2. So I would give 5x squared plus x plus 1. The highest exponent, sum, or the highest number of variables in any of these terms is 2. And I have 3 terms, 1, 2, 3. The second type of examples which you might have are if you're given, it's the opposite now. So if you're given one of these polynomials, you have to state whether it is actually a polynomial, and then whether or how is it classified. So number 1, if we have 18a, b, c minus 12. Well, we can see here that there's 2 terms, so I know it's a binomial. And over here I have, in this binomial, I have a degree of 1, 1, 1, 2, 3, right? There's 3 variables in this one chunk. And over here we have 0. So the highest exponent sum, or the highest number of variables in any one of the monomials is 3. So I have a cubic binomial. The next example is the square root of xy plus 18x squared. First of all, we know that this is not a polynomial, so there's nothing that we need to classify. And the reason why it's not a polynomial is because of this. The square root is being taken of variables, which we know that polynomial only involves addition, subtraction, and multiplication, not square root. So this is not a polynomial. One more example. If we have the example Now this might look like a scary example, but I promise it's not that hard. So, here we have 3x squared y squared z minus 2x cubed y cubed z plus 7x squared y cubed d to the 4th minus 3 to the 10th. Well, first of all, this is definitely a polynomial because we know that no variables are taken square root of, being divided by, or having taken the absolute value of. All is involving multiplication, addition, or subtraction. So now we have to figure out which monomial has the highest number of variables, or the highest sum of exponents. So this monomial, this first one, has an exponent sum of 2 plus 2 plus 1, meaning that there are 2 x's, 2 y's, and 1 z. So if we add that up, we get 5. Over here we have 3 x's, 3 y's, and 1 z. So 3 plus 3 plus 1 is 7. Over here we have 2 x's, 3 y's, and 4 z's, 2, 3, and 4. When you add that up, that gives you 9. And over here, it might look like it's 10, but don't get tricked. There's no variables. Remember that we don't count the exponents, which are on constants. So over here is 0. So we see that the term with the highest exponent, or the highest number of variables, is this one, and we have a degree of 9. So whenever the degree is above 6, there's no specific name, so you just list that the degree is 9. And this has 1, 2, 3, 4 terms, so it doesn't even have a specific name for the number of terms, because it stops, because when we classify polynomials by the number of terms that they have, there's monomial, binomial, and trinomial. Nothing beyond that specifically. So this would just be a polynomial. This would just be called a polynomial with a degree of 9. Thank you for watching my video. I hope that it helped you in whatever you're learning. And if this did help you, make sure to leave a comment below and like this video, share, and subscribe to my channel. If you have any other questions or need further help, make sure to DM me on my Instagram, Simplified by Eman, or you can leave a comment down below. You can also Gmail me at mathsimplifiedbyeman@gmail.com. See you soon!